Now the term resistance. What is the meaning of resistance? It is actually opposition offered by the conductor to flow of the electric current. Let this is conductor and I amount of current is flowing through this conductor. Every conductor has some opposition and that is measured by the term resistance. The opposition offered by conductor to flow of electric current or charge through it is called resistance. It is denoted by the symbol R, or it is measured in the unit ohm. This is OHM and symbol of ohm is here, this one. There are some factors on which resistance of conductor depends. For example, length of the conductor. Let this is length of the conductor. This is cross-sectional area. This area is called cross-sectional area. Third, material of the conductor. Which type of material is this, and what is its constituent elements, and resistivity of the material, temperature of the material. So there are so many factors on which your resistance depends. So let us see. It has been found that resistance of the conductor or wire depends on first factor, length of the conductor. This is length of the conductor. That means here resistance is directly proportional to length. That means you can write here R is directly proportional to, if length is increasing, resistance is also increasing. The graph will be like this. Experiment. There are so many experiments shows resistance of the conductor is directly proportional to the length of the conductor. Second term is here cross-sectional area. This area is called cross-sectional area. This is cross-sectional area. Resistance of the conductor is inversely proportional to cross-sectional area. That means if you are going to trace the graph between R and cross-sectional area, this is cross-sectional area, you will get graph will be like this. And if you are going to trace R between 1 by A, your graph will be like this. Next, combining these two results, resistance, this is equation 1 and this is your equation 2. Now combining these two results, you will get R is directly proportional to L by A, where L is the length of the conductor and A is the cross-sectional area. And here after removing this proportionality, you will get R is equal to here sigma L by A. This is sigma L by A. Here sigma is pronounced rho. इसको हम लोग rho बोलते हैं. Is directly proportional to length of the conductor. This is L length, and R is inversely proportional to cross-sectional area of the conductor. This is called cross-sectional area. After combining these two equations, you will get R is directly proportional to L by A, and here removing proportionality, you will get R equals to rho L by A. This is proportionality constant. This is proportionality constant. Here this is. That means, and this rho depends on the material, and resistance depends on the type of material. In fact, the rho depends the difference in the resistance due to difference of the material. Obviously, the material with high value of rho will have high value of resistance and vice versa. That means rho equals to, you can write rho is equal to, you can write R into A by L. That means here L rho, इसको हम ऐसे लिख सकते हैं, this is L and this will be L into L by L for unit. Unit के लिए हम लोग ऐसे कर रहे हैं, तो resistance के लिए unit हो गया ohm and this is meter. तो इसका unit हो गया, this is unit is ohm meter, or you can write this is meter. This is the resistance. This is the unit of your rho. Unit of rho is this one. Ohm meter and here length cancel, ohm इसके लिए and length इसके लिए हो गया, क्योंकि length into breadth या जो भी होगा तो वो आपका एक length ही होगा, एक length cancel हो जाएगा, तो you will get this. Now the term resistivity, when this is your conductor, let this is any conductor, here let area is unit 1 meter square and length is here 1 meter, length equals 1 meter, and here in this case R is equals to your rho. How will you get this result? When L equals, when resistivity, when L equals 1 meter and area, cross sectional area is 1 meter square, in that case your formula is here, this is equals to R A by L. In that case this is area is 1 1, that means this will be cancel out, that means R is equals to here resistance. Resistivity is here purely resistance. Resistivity of the material is the resistance on the wire of material of unit length and unit area of cross section. Next term on which your resistance depends, the temperature. With the rise of temperature, next term is temperature. With the rise of temperature, the resistance of the material increases and decreases with the decrease in temperature. Now, this is conclusion here. Resistance is directly proportional to length of the conductor. This is L length, and R is inversely proportional to cross-sectional area of the conductor. This is called cross-sectional area. After combining these two equations, you will get R is directly proportional to L by A, and here removing proportionality, you will get R equals to rho L by A. This is proportionality constant. This is proportionality constant. Here this is. That means, and this rho depends on the material, and resistance depends on the type of material. In fact, the rho depends the difference in the resistance due to difference of the material. Obviously, the material with high value of rho will have high value of resistance and vice versa. That means rho equals to, you can write rho is equal to, you can write R into A by L. That means here L rho, इसको हम ऐसे लिख सकते हैं, this is L and this will be L into L by L for unit. Unit के लिए हम लोग ऐसे कर रहे हैं, तो resistance के लिए unit हो गया ohm and this is meter. तो इसका unit हो गया, this is unit is ohm meter, or you can write this is meter. This is the resistance, this is the unit of your rho. Unit of rho is this one, ohm meter, and here length cancel, ohm इसके लिए and length इसके लिए हो गया, क्योंकि length into breadth या जो भी होगा तो वो आपका एक length ही होगा, एक length cancel हो जाएगा, तो you will get this. A cylinder of material 10 centimeter long. Let this is cylinder here, and this is length of the cylinder is here 10 centimeter here, and has cross sectional area, this is 2 centimeter square. If its resistance along the length be 20 ohm, here resistance R is equals to 20 ohm, what will be its resistivity? And you know formula for resistivity is R equals to rho into L by A. Now put the value here, you will get, this is resistivity, that means you can arrange this formula, you will get rho is equals to R into A by L. Here resistance is 20 ohm. Put this value. Area is here 20. Area is here 2 centimeter square. That means this is 2 cm square divided by length is here 10 centimeter. 10 centimeter. That means after cancelling you will get this is equals to here 4 ohm per centimeter. This is 4 ohm. Now convert it into meter, you will get 0.04 ohm. Now sign convention in Kirchhoff's rule. Kirchhoff's second law is based on energy conservation, because if net electric potential in a closed path is not equal to 0, then in such case charge will continuously gain energy by circulating around loop itself. Your circuit is like this. This is your circuit, this is battery, and this is resistor. This resistance is R1. Here battery EMF is E1, and here next resistor, this is R2, and here another cell is this one, and this is here E2, and current is flowing like this current is flowing, I amount of current is flowing through the circuit, and this is. Now let the direction here clockwise. This is clockwise direction. In this closed loop, algebraic sum of EMF is equal to algebraic sum of potential drop across the resistor in the loop. That means you can say this is sigma E plus sigma IR is equal to 0. While traveling along the direction of current through the resistor, the potential drop IR is considered to be positive. While traveling opposite to the direction of current, potential difference, your potential drop or potential difference IR is considered to be negative. For example, if your resistor is like this one, this is resistance, and current is flowing in this direction, and our sign convention is like this. तो साइन कन्वेंशन के थ्रू हमने मान लिया पाथ ऐसे लिया है और ये इस तरह से है. इफ बोथ आर इन सेम डायरेक्शन, दैट मीन्स हियर आई आर विल बी पॉजिटिव, एंड इफ इट इज इन ऑपोजिट डायरेक्शन, लेट करंट इज मूविंग लाइक दिस एंड आवर पाथ इज दिस वन, दैट मीन्स आई आर इज हियर नेगेटिव. IR is negative, that means this is potential drop across the resistor, and here 2 points are important in your applying Kirchhoff's law. तो Kirchhoff's law लगाते समय ये 2 पॉइंट ध्यान में रखना है. पहला पॉइंट ये कि हायर से लोअर अगर डायरेक्शन आपका जा रहा है, आपका जो डायरेक्शन जो लिए हैं वो डायरेक्शन, करंट का डायरेक्शन से नहीं मतलब है आपके डायरेक्शन को. तो इफ बोथ आर इन योर हायर टू लोअर, तो यानी कि हायर टू लोअर में EMF पॉजिटिव, एंड हियर लोअर टू हायर EMF विल बी नेगेटिव, एंड हियर both are in same direction, IR will be positive, and both are in opposite direction, IR will be negative. Now apply. तो अप्लाई करते हैं. तो इसमें देखिए हायर टू लोअर, दैट मीन्स EMF विल बी पॉजिटिव प्लस दिस इज. तो फिर अब ऐसे जाएंगे. देखिए हमारा डायरेक्शन ऐसे है ये, और ये IR ऑपोजिट डायरेक्शन में करंट कुछ इस तरह से जा रहा है, तो ये नेगेटिव हो गया. दैट मीन्स यू हैव टू राइट माइनस IR2, एंड हियर लोअर टू higher, that means minus E2, and this is here again. देखिए करंट का डायरेक्शन डाउनवर्ड है, हमको जाना होगा अपवर्ड, जो हमने पाथ लिया है. आप क्लॉकवाइज एंटी क्लॉकवाइज कोई भी ले सकते हैं, अकॉर्डिंगली चेंज होगा उसका. हियर दिस इज योर माइनस IR1 is equal to 0, and this is here E1 minus E2 is equal to IR2 plus IR1. You can write. This is Kirchhoff's second law. This is the problem based on your sign convention in Kirchhoff's rule. Here, you know, the algebraic sum of EMF and IR drops of a closed loop are kept equal to 0. Here now apply. This is, let us assume clockwise. हम अपना clockwise एक ले लेते हैं direction. Let this is clockwise direction. Here there are 2 loops. देखिए फिगर देखने से पता चल रहा है, there are 2 loops, first loop and second loop, और हम लोग ले रहे हैं इसको clockwise. This is loop 1, this is loop 2. For loop 1 circuit ABEF, this is rectangular loop, and we are going to start from E1. This is E1 here. तो यहाँ से E1 से हम स्टार्ट करते हैं. E1 से देखिए साइन कन्वेंशन, एज पर साइन कन्वेंशन हायर टू लोअर पोटेंशियल हमारा डायरेक्शन है, हायर टू लोअर. that means E1 will be positive. E1 is positive. And next here R3. R3 is here. Here current will be, this current is I1 and this current is I2. That means here you can write this is negative of I1 plus I2 into R3. इन दोनों का ये सम हो गया करंट. एंड हियर रेजिस्टेंस इज R3. तो हमारा देखिए डायरेक्शन जो है अपोजिट है. यहाँ देखिए डायरेक्शन जो है अपवर्ड है और आवर डायरेक्शन इज बिलो, डाउनवर्ड. तो ये देखिए दोनों अपोजिट होने के कारण दिस इज नेगेटिव साइन. एंड अगेन दिस इज माइनस R1. दिस इज, यहाँ हमारा डायरेक्शन देखिए अपवर्ड है, दिस डायरेक्शन इज डाउनवर्ड, दिस इज डाउनवर्ड. सो हियर एंड करंट इज I1 माइनस I1 R1 is here. And here for internal resistance of the battery, again internal resistance के लिए देखिए our direction is your rightward, this is leftward. तो इसके लिए भी लिखेंगे this is minus I1 R1. Internal resistance is denoted by here small r1 and this equal to 0 because the algebraic sum of EMF and IR drop of a closed loop are then kept equal to 0. And apply the same concept for loop 2. For loop, now for second loop B, C, D, E, B, here this is lower to higher. Our direction is lower to higher, that means this is minus E2 and this is again here, this is same direction, that means plus I2 R2 and here this is अगेन वन मिसिंग. यहाँ पे भी एक और है रेजिस्टेंस आपके लिए, इंटरनल रेजिस्टेंस. इंटरनल रेजिस्टेंस का भी डायरेक्शन सेम है. सो दिस इज हियर I2 R2 इंटरनल रेजिस्टेंस एंड दिस वन इज हियर R3 एंड दिस आर इन योर अगेन सेम डायरेक्शन. एंड हियर करंट इज I1 प्लस I2. दैट मीन्स यू कैन राइट I1 प्लस I2 इंटू R3. दिस इक्वल टू 0. Let us take another question of sign convention in Kirchhoff's law. Using sign convention, we are going to write equation. What will be equation? तो देखिए इससे भी प्रैक्टिस कर सकते हैं. एक दूसरा हम केस लेते हैं. यहाँ भी आपको समझाना चाह रहे हैं कि साइन कन्वेंशन कैसे अप्लाई करेंगे. हाउ विल यू अप्लाई द साइन कन्वेंशन इन योर गिवन क्वेश्चन. तो लेट अस टेक लूप क्लॉकवाइज. हमने क्लॉकवाइज यहाँ पे लिया है. तो ये लेटेस्ट दिस इज हायर पोटेंशियल, दिस इज लोअर पोटेंशियल. आप इसको डिनोट करने के लिए HL लिख सकते हैं. H stands for हायर पोटेंशियल. ये किसी भी सेल के लिए हायर पोटेंशियल है. दिस इज लोअर पोटेंशियल. तो हियर एंड दिस इज हायर, दिस इज लोअर. तो देखिए यहाँ पर हमारे पास अगर डायग्राम को हम इस तरह से बनाते हैं, देखिए ये हमारा कुछ इस तरह से होगा डायग्राम. दिस विल बी योर डायग्राम. तो हियर करंट इज द डायरेक्शन ऑफ योर आवर लूप इज H to L. That means E1 will be positive. E1 is positive. And here this and this is in same direction. That means current and here our assumed loop both are in same direction. That means here this is IR1 plus here again H to L, higher to lower. And the direction of current is from higher to lower potential. So this is here E2 is positive again. Here I देखिए both are in same direction. देखिए assumed loop ये हो गया और ये current का direction both are in same direction. That means here I R2, this is IR2 and this sum is equal to 0. तो देखिए using sign convention and Kirchhoff's rule we have written this equation and now this equation is useful. In this question A, B, C, D, E, F, A is the circuit and here two loops are there. First one is A, B, E, F, A and second one is B, C, D, E, B. Second loop. So here we are going to apply first your Kirchhoff's first law, that is junction law. Junction law at B. Junction law at B. Let here I1 current is entering and I1 current देखिए दो पार्ट में डिस्ट्रीब्यूट हो गया. Let this is current is your I1 and here this current is divided in two part. This is I3 and let this is I2. तो देखिए यहाँ से इनकमिंग करंट है. दिस इज, ये हमने एक जंक्शन लिया तो हम इनकमिंग करंट एट B is your I1 that means incoming current is equal to sum of outgoing current. Outgoing current is here I2 plus I3. That means you can write I1 minus I2 minus I3 is equal to 0. This is equation 1 from Kirchhoff's first law, junction law. Now applying Kirchhoff's second law in loop 2. Loop 1, this is loop 1 and this is loop 2. Applying Kirchhoff's law in loop 1. This is loop 1, this is loop 2. तो देखिए इसमें अगर लगाएंगे डायरेक्शन तो देखिए हमने जो डायरेक्शन लिया है, दिस इज करंट इज हियर I1 करंट, दिस इज I3 करंट एंड दिस इज I2 करंट. तो देखिए I2 यहां से निकला, इट बिकम्स I1 हियर. I3 प्लस I2 I1 हो गया यहाँ पे. तो करंट का डिस्ट्रीब्यूशन पहले समझ लीजिए. दिस इज करंट डिस्ट्रीब्यूशन एंड वेरी इंपॉर्टेंट. फर्स्ट यू हैव टू अप्लाई करंट डिस्ट्रीब्यूशन एंड यूज जंक्शन लॉ. तो जंक्शन लॉ यूज करके देखिए I1 करंट को ब्रेक किया और यहां से फिर ये दोनों I2 प्लस I3 मर्ज होकर ये देखिए बन गया I1. दैट मीन्स इस सर्किट में यहां से यहां तक जो है I1 करंट है. तो हम लोग लगाते हैं आपके लिए यहाँ पे आपका ये अप्लाइंग किरचॉफ्स सेकेंड लॉ इन लूप 1. लूप 1 इज हियर, दैट मीन्स यू कैन राइट अप्लाइंग किरचॉफ्स लूप लॉ इन लूप 1. तो देखिए फर्स्ट लूप में लगाते हैं तो देखिए करंट का डायरेक्शन और हमारा जो लूप था उसका डायरेक्शन सेम है. दैट मीन्स दिस इज 4I1 और ये देखिए डिस्ट्रीब्यूट होकर हो गया ये I2 देखिए लोअर से हाइयर जा रहा है. ये लोअर टू हाइयर डायरेक्शन हमारा ऐसे है, लोअर टू हाइयर. दैट मीन्स दिस इज योर -4 वोल्ट. तो -4 लिख देते हैं सिंपली. यहाँ पे देखिए ये आने के बाद यहाँ पर I1 है और ये देखिए दोनों सेम डायरेक्शन में है, करंट का भी डायरेक्शन और ये भी. तो दैट मीन्स यू कैन राइट दिस इज +2I1 एंड हियर अगेन लोअर टू हाइयर, दैट मीन्स दिस इज -2 इज इक्वल टू 0. -2 इक्वल टू 0. तो देखिए आपके पास इक्वेशन बन गया. नाउ अप्लाइंग किरचॉफ्स लूप लॉ इन सेकेंड लूप. सेकेंड लूप is B, C, D, E, B loop. For this loop, Kirchhoff's loop law, here 2 ohm and current are in same direction. That means you can write this is 2I3 positive. Higher to lower. That means this is 6 positive. Here this is current and loop direction same. That means this is 4. Here current is I3. I3 amount of current is passing through this and this is here I2. Here in this circuit current is I2. That means this is 4 volt is equal to 0. This is equation 3. Now after solving equation 1, 2 and 3 we get I1, I2 and I3. Here 3 unknowns I1, I2 and I3 and 3 equation 1, equation 2, equation 3. After solving equation 1, 2 and 3 you will get the value of I1 will be 1 ampere. ये आप इसको सॉल्व कर लीजिएगा. इसको सॉल्व करने पे आपके पास वैल्यू आ जाएगा I1 1 ampere. I2 is your equation, I2 is your 8/3 ampere. And I3 is -5/3 ampere. I3 -5/3 ampere. Here I3 is negative because here I3 is in opposite direction of what we have assumed. Actual direction of I3 is here negative. जो हमने assume किया है उसका opposite है. So I3 is here negative. So your value will be I1 is 1 ampere, I2 is 8/3 ampere, I3 is -5/3 ampere. ये कैलकुलेशन है. अब इस कैलकुलेशन को लीनियर इक्वेशन ऑफ 3 वेरिएबल जैसे सॉल्व करते हैं उसको सॉल्व कर लीजिए और सॉल्व करने के बाद आपके पास ये आ जाएगा. The current in the wire varies in time according to the relation I equals 3 ampere plus 2 ampere per second time. How many coulombs of charge pass a cross section of wire in the time interval between t equals to 0 to t equals to 4 second And what is the second part of this question is what is the constant current. Here you have to find the current and here you have to find the charge, and here this is given here time and current relation. So you know dq dt, that implies dq is equals to I dt, and here you have to integrate it from time interval 0 to 4 second. That means integrate dq 0 to q, this is amount of charge, and here I is given here 3 plus 2t, that means 3 plus 2t is current. करंट आपका दिया हुआ है गिवन एक्सप्रेशन I equals 3 plus 2t here, and here this is dt, and time interval is here 0 to 4 second, 0 to 4. Now integrate dq, integration of dq is q here, and you have to put the limit 0 to q, and here 3 dt integration 3t plus this is 2t square by 2, and now put the limit, and here limit is 0 to 4. अब इसको सॉल्व कीजिए, you will get your answer. This is here q minus 0, that means this is q, and here this is 3 into 4 plus this will cancel out, that means 4 square, that means q is equals to here this is 16 and this is here 12, 16 and 12, that means 28 coulomb is answer. In second part of this question you have to find the current. Here current is equals to q by t. q is here हमने evaluate किया था, q is 28 coulomb and time is here 4, that means 28 by 4, that means here 7 coulomb is answer, that means 7 coulomb per second, or you can say ampere.